This video will explain the concept of a sampling distribution for a difference in sample proportions and go through an example of how to do calculations with this type of sampling distribution. So for my example, let's say I want to calculate the difference in proportions of students that are wearing Crocs among a sample of freshmen and among a sample of seniors. So here I've got my population of all the freshmen and my population of all the seniors. The first thing I'm going to do is take a random sample of freshmen from the population of all freshmen, and I'll also take a random sample of seniors from the population of all seniors. So now I've got my smaller sample of freshmen and sample of seniors. I'm going to calculate the proportion of students that are wearing Crocs within my sample of freshmen. So let's just say 40% of my freshman sample is wearing Crocs, so the sample proportion is 0.4. Then I'm going to calculate the proportion of students wearing Crocs within my sample of seniors. So let's say within my sample of seniors, 70% of them are wearing Crocs, so the proportion would be 0.7. So the next thing I'm going to do is find the difference in those proportions. So 40% of my freshman sample was wearing Crocs, and I'm going to subtract 0.7 because 70% of my senior sample was wearing Crocs. So that gives me a difference of negative 0.3. So I'll take that difference of 0.3 and I'm going to plot it on a graph. So again, this graph is going to show the difference between the proportion of the freshman sample wearing Crocs and the proportion of the senior sample wearing Crocs. The difference that I calculated was negative 0.3. So I don't know exactly what scale to make yet. I'll just put that here. This is negative 0.3. And I'm going to put one dot here to show that I got one difference between sample proportions of negative 0.3. Okay, so now I'm going to go back to my population of all freshmen and take a new sample of freshmen, go back to my population of all seniors and take a new sample of seniors. From my sample of freshmen, I'm going to calculate the proportion wearing Crocs. Let's say this time the proportion was 45%. So 0.45. And I'm also going to calculate the proportion of students wearing Crocs in my new senior sample. So let's say this time it was 0.72. So now I'll calculate the difference in those proportions. So 45% of my freshman sample was wearing Crocs, 72% of my senior sample was wearing Crocs. So that is a difference of negative 0.27. Now, again, I don't totally know what to make my scale here. Maybe I'll make this negative 0.25. So then negative 0.27 would be somewhere around here. And I will put a dot to show that I got a difference of negative 0.27. Then I repeat again. So I take a random sample of freshmen from my population of freshmen. I take a random sample of seniors from my population of seniors. From my sample of freshmen, I calculate the proportion wearing Crocs. Let's say this time it was 0.37. I calculate the proportion of students wearing Crocs among my sample of seniors. Let's say this time it was 0.71. I calculate the difference in those proportions. So let's say 0.37 minus 0.71. Which is negative 0.34. So back on my number line graph, negative 0.34 is going to be somewhere around here. So I'm putting a dot to show that I got a difference in proportions between my samples of negative 0.34. So this process will get repeated many times of taking a sample of one population, a sample of the other population, calculating the proportion within each sample, subtracting those proportions to find the difference between the proportions. Now, eventually, if I repeat this process enough times, my distribution of the differences in the proportions is going to start to look more and more like a normal distribution. And that's where we can start to do some fun calculations. So let's try to do an actual problem with this scenario. So let's say the question I want to investigate is, what is the probability that a higher proportion of the senior sample will be wearing Crocs than the freshman sample? One thing the question will also need to tell you is how big the samples are. So let's say I'm taking a sample of 30 freshmen and 60 seniors. Something else we'll need to know to answer this question is the true proportions within our population. So let's say the true proportion of freshmen wearing Crocs today is 0.44, and the true proportion of seniors wearing Crocs today is 0.72. This gives us all the information that we need to answer our question, which again is, when we take our sample of 30 freshmen and our sample of 60 seniors, what's the chance that the senior sample is going to have a higher proportion of students wearing Crocs than the freshman sample? Okay, I'm going to switch over to my whiteboard here since I'm going to do a bit of writing. So before we go any further with the problem, there are some conditions and assumptions that we need to check. First of all, if we are calculating sample proportions, we want to make sure that we're doing this in a binary context with a success and failure that we can define. So in this case, we'll say that our success is that a student is wearing Crocs today, and our failure is that a student is not wearing Crocs today. Oops. We also want to make sure that our samples are going to be independent of each other. So the sample I'm pulling from the freshmen is not going to affect the sample that I'm pulling from the seniors. We can usually assume that that's true. It's important that each sample be of a set number, and that's not changing. So I'm going to use the notation N1 to mean the size of my freshman sample. So we said we'll take 30 freshmen, and then N2 means the size of my senior sample. So we are taking 60 seniors. So those numbers are already set. We also want to make sure that the probabilities are not changing as we draw our samples. So it's always going to be true that our P1, the chance of a freshman wearing Crocs, is going to be 0.44. And our P2, which is the chance of a senior wearing Crocs, is going to be 0.72 always. So those are staying the same. Now, related to independence, we need to check what's called the 10% condition. When we're sampling without replacement, taking those samples out of the population is going to change the probability for our next draws a little bit. This is a negligible amount of change as long as our sample is a small portion of the population. So we're going to go ahead and assume for our 10% condition, we are going to assume that 30 is less than 10% of all the freshmen. And we're also going to assume that 60 is less than 10% of all the seniors. So we can treat each student as independent. Lastly, we're going to check our large counts condition. So remember we said that as we continue to plot those differences in proportions, eventually they will form a normal distribution. But that's only true if we need the sample size times the chance of success, in this case, the chance that somebody is wearing Crocs, to be greater than or equal to 10. So this is going to be 13.2. And we also need the sample size times the chance of failure to be greater than or equal to 10. And we need to check that this is true for both samples, just like how we checked the 10% condition for both samples. So we also need to check that 60 times 0.72 and 60 times. So yes, all of these counts of predicted numbers of successes and predicted number of failures are greater than 10. So we have met our large counts condition, and this distribution can be modeled with a normal distribution. So I just rewrote some of that key information here. We're treating our population 1 as freshmen and population 2 as seniors. So we're taking samples of size 30 with chance of success 0.44 from the freshmen, samples of size 60 with chance of success 0.72 from the seniors. And again, in this case, success means that a student is wearing Crocs today. Now, what we're investigating is the difference between the proportions from our samples. So when I take a sample from the freshmen and I calculate the proportion that are wearing Crocs, that is P1 hat because it comes from a sample, not a population. So the hat shows that it is a sample statistic. When I take a sample of the seniors and calculate the proportion that is wearing Crocs, that is P2 hat because it is a sample statistic. And what I'm interested in is the difference between those. So this is our random variable of interest is P1 hat minus P2 hat. So I need to calculate the mean of that random variable. And based on the formula, this is just P1 minus P2. So in this case, it will be 0.44 minus 0.72.8. I also need the standard deviation of the difference in the sample proportions. You also have a formula for this. So in this case, it will be the square root of 0.44 times 0.56 over 30 is 0.72 times 0.28 over 60. Be really careful as you're typing these calculations into your calculator. I definitely recommend doing the square root on its own as a last step. So I'm getting 0.108 as my standard deviation of the difference between those proportions. So let's use our mean and standard deviation to set up a normal distribution curve. Okay, so here is my normal curve, and I'm going to put the mean in the center, which we said was negative 0.28. And each of these lines represents one standard deviation above or below that mean. Standard deviation was 0.108. So if I do negative 0.28 and then I add 0.108, that puts me at negative 0.172064. Here I will be at 0.044. To go in the other direction, I would subtract a standard deviation. So negative 0.28 minus 0.108 would give me negative 0.388, for example. So again, the question we were trying to answer is the probability that the proportion of the senior sample wearing Crocs is greater than the proportion of the freshman sample wearing Crocs. The distribution that we made here is the distribution of freshmen minus seniors. So if the senior proportion is greater than the freshman proportion, then when we subtract, we'll get a negative number. So we are looking for this difference to be negative, to be less than 0. So on my distribution, 0 is going to be somewhere between negative 0.064 and positive 0.044. And we want everything to the left of that. We're looking for the chance that the difference in proportions is less than 0. So if you have a graphing calculator, you can calculate that area, that probability, by doing norm CDF. We're going all the way to the left, so you would just pick a really low negative number as your lower bound. Our upper bound is going to be 0, because we want to go up until 0. The mean is negative 0.28, and the standard deviation is 0.8. So if you calculate that, you should get 0.99. That is 0.995. Now, if you don't have a graphing calculator, you could also calculate the z-score. So our value would be 0 minus the mean, negative 0.28 divided by the standard deviation of 0.108 is 2.59. Then I would grab a z-table and look for the z-score of 2.59. Here's my 2.5s, and then I'm going to go all the way down to 2.59. And I'm seeing that the area to the left is 0.9952. So you should be getting the same answer whether you use the calculator or the z-table. So what does this mean? This means that if we take a sample of 30 freshmen and a sample of 60 seniors, we find the proportion of students that are wearing Crocs within each sample, and then we subtract those differences. There's a 99.5% chance that that difference is going to be less than 0. There's a 99.5% chance that we'll have a higher proportion of our senior sample wearing Crocs than our freshman sample wearing Crocs. So hopefully this video was helpful in understanding the concept behind a sampling distribution for a difference in two sample proportions.